Hello and welcome. Today we are learning sets video number 10 and today we are going to learn about Venn diagrams. Now Venn diagram was first proposed by John Venn, great English mathematician or logician, and so we use the word Venn diagram in his honor. His name was John Venn. So he was the first person to actually propose that sets we should be able to represent them visually. Now recall, up until now, we have seen only two representations of set. One is the roster or tabular form, and the second one is the set builder form. These are only two ways we have learned so far how to write a set. I hope you have listened or watched those videos that I mentioned. If not, I'm going to provide the video links in the top right corner of this video. Please go do check it out. So what did John Venn exactly propose? So John Venn, he suggested that we can draw a universal set in a form of a rectangle. So let's draw a rectangle. So let's say this rectangle, this big rectangle represents a universal set. In the last video, we have learned what is a universal set. So universal set we represent by uppercase letter U, and universal set means everything, and it is in the context. So if you're talking about numbers, and we'll take a look at a lot more examples. So if you're talking about numbers, universal set could be collection of all numbers, right? If you're talking about maybe some movies, it could be collection of all movies. If you're talking about some books, it could be collection of all the books in the world. If it is, if we are having a conversation about population, it could mean all people on planet Earth, so on and so forth. So now he said, so a rectangle represents a universal set, and any set which is a subset of U, we draw it inside this rectangle. And that subset we draw typically in a form of a circle, like a closed curve. So let's draw a circle. So let's draw a circle like this. And this circle represents a set A. So here what we have is we have set A, it is inside of U, so we know that set A is a subset of our universal set. We know what is a subset. I'm going to provide the video link for that in the top right side corner as well. So now let's say we write the set A as, let's write some elements for set A. So let's say we have set A contains number 1, number 2 and number 3. These are three elements of set A. So how do we represent these three elements? So the set itself is inside of U. So the elements then must be inside A. So now we can arbitrarily take any 3 points. Maybe this is 1, maybe this is 2, and maybe this is 3. It does not really matter how we write them. The important thing is as long as we write them inside of the circle. Because the circle shows the set A. So inside of the circle should contain all the elements that belong to A. So then what is actually outside A? Now, okay, let's see this. So what about number 4? Does number 4 belong to set A? Well, A has 1, 2 and 3. So 4 does not belong to A. That means, but 4 is a number, it is definitely part of universal set, so it should be inside of the rectangle, but it cannot be inside the circle. So then maybe we can put 4 like this. This is 4. Similarly, 5, it does not belong to A. So maybe we can put 5 over here. And again, I'm randomly positioning 4 and 5 or any other point. As long as these points, they are outside of the circle, that is all we are trying to accomplish. Because points that are elements of a set must be inside of the circle that shows the set, and any element that does not belong to the set must be outside. Because they are numbers, they are still within our universal set, right? Now let's take a look at some more examples, and now through those you will be able to see how this way of looking at sets is so fascinating and it is so revolutionary, because literally by looking at the set we can qualitatively say so much about the sets without knowing really a whole lot of information about them. So let's say here, this is the first example. So the circle, or this more looks like an oval. So let's say this represents our set A, and this is a universal set, right? Let's take a look at a second example. Here we have two sets. So this is set A, and this is set B, and this is a universal set. Now here, without really knowing a whole lot about set A and B, one thing we can tell right away. That is, set A and set B, they do not have any common element. Why do we say that? We know that the circle represents the set, and all of the elements that belong to A must be in here, right? Similarly, all of the elements that belong to B must be inside here. So there is nothing in B which is outside. Similarly, there is nothing in set A which is outside this circle. So A and B are two separate circles. That means they have no elements that are common. So this leads us to the third example. As you can imagine, here we have overlapping circles. So this is set A and this is set B. So, and this is a universal set, which is a rectangle. So here, let's change the color a little bit. So here we can see that this part is actually common to both the circles. That means this part represents the common elements of set A and set B. So for example, we can think of this as, let's do it over here. Let's say our set A is represented as the number 1 and number 2. And let's say our set B has elements, the number 2, 3, and 5. So here we see that number 2 is common to set A and set B. That means we can safely say that our number 2 must be over here. So what about the rest of the elements? Well, the rest of the elements for A, so this circle should show all elements of A. A has 1 and 2. So if 2 is in this common part, so 1 can be anywhere. So let's say 1 is here. Now for set B, it has 2, 3, and 5. So if 2 is here, maybe 3 is here and 5 is here. So this is how we actually write elements inside of a set and set inside of a universal set. All right, so let's take a look at some more examples. What can we see over here? Well, here we have like one circle inside another circle. So because there are two circles, we are dealing with two sets. So outside one is a universal set, which is a rectangle. Then outside circle, let us call it B, and inside circle, let's call it A. Remember how we actually write the set. We draw the circle and write the set outside of it. So like the way we have drawn the rectangle, and the representation of the rectangle is outside, right? So here B represents the outside circle and A represents the inside circle. So now in the first example, because A is inside U, so we know that means A is a subset of U. We have learned subsets before. So here B is a subset of U. We can see that because B is inside U. A is also a subset of U. A is inside U. But additionally, we see that A is inside of B. That means what? That means set A is a subset of B. Or B is a superset of A. So see how powerful Venn diagram is. We at this point have not even talked about the elements that make up these sets. By looking at the Venn diagram representation of the sets, we are able to qualitatively get all this information. Let's take a look at one last example. So now this time, let's say we have all these circles. So outside rectangle is a universal set. And then the first circle, let's call it set A. Then this one, let's call it B. Then this one, call it C. And the last one is D. So we see that set A has no common elements with B, C, or D. What can we say of set B and C? Well, we can see that for B and C, they do share common space like this. That means B and C, set B and C have common elements. And similarly, we see that set C and D, they have this common area or this common part. So C and D also, they share common elements. But what about set B, C and D? Three of them combined, do they have any common elements? They don't. So this is how we can actually get so much information from Venn diagram, and why Venn diagram is such a powerful way to represent the sets. And in the next few videos, we are going to learn so much more about Venn diagrams, and we're going to solve lots of problems involving Venn diagrams and different operations on sets.